If you enjoy Astronomy FM radio, please let us know with a small donation. We do rely on your support, and it's true. Every little bit counts.
AFM. You are listening to a universe of possibilities. This is Astronomy FM.
Coming up next, an Astronomy.fm original program. It's time for York Universe, a co-production of the Observatory of York University, Toronto, and the Voice of Astronomy. AFM Radio, AFM Radio, AFM Radio, AFM Radio.
Hello, everybody, and welcome to York University Astronomy and Astrophysics program, written and presented by the students and faculty at York University. I will be one of your hosts this evening. My name is Jesse Rogerson, and tonight we have two amazing hosts. One is Leanne Manzer.
Hello, everybody.
The triumphant return of Leanne Manzer, and also Paul Delaney.
G'day, folks.
He's got to get his good day in there. We are, of course, broadcasting live from the York University Astronomical Observatory in Toronto, Canada, and tonight, well, it's Astronomy Night in Canada, right? Where the entire lineup is Canadian, starting with us, York Universe, moving on to Western Worlds, then Skeptically Speaking, and wrapping with Quirks and Quarks. All great programs. Make sure you stick around and listen to them after us. And of course, the broadcast that we're doing now, York Universe, is in concert with another program that our observatory runs. It's called Online Public Viewing. If you don't know what that is, we run it every Monday night at the same time. It's not open yet, but it will be open. If you head to yorkobservatory.com, it's basically a place where you can virtually interact with our observatory. Not only do we show you images from archives, you also get to talk to the people who actually work at the observatory. So head on over to yorkobservatory.com right now. It'll be open momentarily, and that chat room is only on Monday nights. Of course, our broadcast, the one you're listening to right now, comes every Monday night, 9 p.m. local Toronto time, and we're powered by the amazing people at astronomy.fm. Thanks for listening, everybody. And time to talk a little bit of York astronomy. How's it going?
Sounds good. So, Jesse, let me just give a quick update on what will be happening at the online public viewing this evening. As it works out tonight, we have a tour of about 50 folks who have rained down upon the observatory, and therefore will be keeping everybody very, very busy and hopping there. It is a little murky outside at the moment, so the observing team will be doing sort of double duty. We are hoping to get a webcam image up of the moon while we are using the telescope to show people images of the moon. So it'll be a little bit of a catch as catch can for the first hour or so over at the observatory. It doesn't stop the chat room being a terrific place of conversation. So yorkobservatory.com, by all means, send on over your favorite web browser to that location. But just to give everybody the heads up, there won't be a lot of new images other than the moon being thrown up tonight because of the traffic, shall we say, in and around the dome.
And on that note, the chat room is not the only way that you can contact us, both right now and anytime. You can always just Facebook, tweet, or email us. And you can, for York Universe, if you go to yorkuniverse.com, we're always playing around with that website. So you can drop us a line there. You can send us an email. We love tweets. In fact, if you tweet us during the show, that's amazing, because then we can answer your tweet live if you have a question. So you can use any form of communication you please. Except for shouting.
Shouting doesn't work. But yeah, Jesse and I are monitoring Twitter right now. So if you tweet either one of us or York Universe, we'll be right here and we can talk about it on air.
Okay, should we move on to the first thing?
Sounds like an extremely good plan to me, folks.
We always start the night, the show. It's morning, I guess. It is morning. We always start the show with This Week in History, This Week in Space and Astronomy History. And I'll pass it to you, Paul, because you like the birthday.
Absolutely. I've been practicing my happy birthday greetings all day. Okay, so here it goes. Happy birthday. I don't want to sing. My parents keep telling me I should stop doing that sort of thing. But anyway, it's a big shout out. Happy birthday to the NASA administrator himself, Charles Bolden. I'm told Chuck to his friends, but that means it's Charles to us. So at any rate, he, of course, is the current NASA administrator. But what a lot of people may not know is that he is actually the veteran of 3 space shuttle missions. So this is a guy leading NASA who has really been in the thick of it all through the 80s and into the 90s. STS-45, 61C, and STS-31. He was the commander of STS-45. So he's been a very busy astronaut, retired from the astronaut corps, assumed all sorts of roles within NASA, and then ascended to the, in some senses, unenviable position, in my opinion, of being the NASA administrator. You'd think that'd be the best job in the world for a space scientist, an astronaut, and so on and so forth. But gosh darn, the politics that you got to deal with. Hat goes off to any of the NASA administrators. Not a real great job, in my opinion, but I'm sure they love it, and that's great, and I'm delighted that he is there. He has known so much about NASA from the inside out. So happy birthday to Charles, born August 19th, 1946.
And so there's another August date that is associated with him that, we could cover next week, but I thought we'd bring it into this one.
Not a
On
real
August
great
28th,
job,
2012,
opinion,
he was the first human being to have his voice broadcasted on the surface of Mars. And that was, of course, through the Curiosity rover.
No way, really?
Yeah.
So
Cute,
they just play.
I can actually read a bit of it.
Yeah, well, tell us what they said.
Hello, this is Charlie Bolden, NASA administrator, speaking to you via the broadcast capabilities of the Curiosity rover.
Who's he speaking to?
Which is now on the surface
Attention,
of Mars.
all Martians. Attention, all Martians. Oh, I'm sorry.
Since the beginning of time, humankind's curiosity has led us to constantly seek new life, new possibilities just beyond the horizon. I want to congratulate the men and women of our NASA family, as well as our commercial and government partners around the world, for taking us a step beyond to Mars. This is an extraordinary achievement. Landing a rover on Mars is not easy. Others have tried. Only America has fully succeeded. This investment we are making, the knowledge we hope to gain from our observations and analysis of the Gale crater, which will tell us much about the possibility of life on Mars, as well as the past and future possibilities for our own planet. Curiosity will bring benefits to Earth and inspire new generations of scientists and explorers, as well as it prepares in a way for a human mission in the not-too-distant future. Thank you.
Now, that's the cool part about being the NASA administrator.
That is
the only cool part. So I guess what he was doing is they played it on through the rover's capabilities and then played it back to Earth. That's the idea.
Like.
Oh, so it wasn't attention all Martians, it was attention all Earthlings.
That's how started my one, for sure.
Yeah.
Excellent. Well, as I say, that's definitely the cool part. But excellent. All right, so happy birthday, Charles.
And moving on to our second one. And Paul, I'm going to let you do this one too because I don't know much about it.
I know, you weren't born then. We've been through this. August 20th, 1975, the launch of Viking 1. And given the fact that Leanne just updated us about the NASA Mars broadcast, Viking 1, of course, and the sister craft Viking 2 were arguably the two vehicles that set the stage, that sort of laid the table, whet our appetite for Spirit, Opportunity, Curiosity, Pathfinder, all those missions, those exciting missions of this century and the late 1990s. Viking 1 was a two-part probe that had an orbiter and a lander. And, of course, the orbiter was in orbit around Mars for a number of years. I've forgotten whether it was 3, 4, or 5 years, but a number of years taking orbital surveillance images. And Viking Lander 1 landed on the surface of Mars July 20th, 1976, 7 years to the day after Neil Armstrong set foot upon the moon. So Viking 1 led the way, if you will, for our in-depth, up-close and personal investigation of the planet Mars. And it launched August 20th, 1975. And needless to say, I remember watching that launch. It wasn't live because there was no such thing as the internet back then, but it was played on the Australian Evening News, and Viking Lander 1, when it landed on the surface of Mars, July 1976, the lockup, shall we say, to the transmission from the surface took place during the Tidbinbilla tracking station's pass, and that was the main radio communication dish of NASA's 3 dishes around the world. It's a station just outside of Canberra, Australia, and I was studying in Canberra. So it was big news in the Canberra newspapers all through the Viking 1 mission. So it all started August 20th, 1975.
And moving along, continuing on with the space exploration, would be our next This Week in History on August 29th. August 29th, 1977, was the launch of Voyager 2. So Voyager 1 and Voyager 2 are the furthest spacecrafts we've ever sent away from Earth, the furthest things we've ever sent out into space, not including radio waves. Voyager 2 was launched first for some reason. It was dependent on the window and where they were going, I suppose, as Voyager 1 and Voyager 2 had slightly different paths through the solar system. But this is a great anniversary for Voyager 2 because it lines up not only with its launch on August 29th, 1977, but its flyby of Saturn, August 25th, 1981, and then its flyby of Neptune on August 25th, 1989. So this sort of part of August is really good for Voyager 2.
The cool thing about this stat, I feel, is that it was launched from Earth 1977, arrived at Saturn, what is that, 4 years later? Sorry, arrived at Saturn 4 years later, and then it arrived at Neptune an additional 8 years after that. So I know there's planetary motions in that as well, I mean, the speed of the spacecraft, but it really took a long time for it to get, quite a big distance out there.
I also have to apologize on behalf of my poor typing ability. Jesse was reading the show notes that I put in, and yeah, sorry, Jess, it wasn't August. It wasn't August 29th. It was August 20th. I'm sorry about that.
At that point, Jesse looked at me like, "We're doing another one for next week. What are we doing?"
That was my question. I was like,
I know. I heard it in your voice. The listeners mightn't have, but I feel suitably chastised. I hit the 9 instead of the 0. So it really was a launch on August 20th, 1977, Jesse.
My apologies, everybody listening. I didn't mean to mess that up.
Well, I messed you up. I mean, you were trusting me, and I blew it. I'm sorry.
The Voyagers are such a great. This is Harrison's. Harrison is a host here on York Universe, and this is Harrison's favorite topic, the Voyager spacecrafts, because it's so many different things. They were revolutionary planet in terms of planet exploration. The number of planets they hit. Voyager 2 is the only one to see Uranus and Neptune. Still, there's been no other spacecraft
both of them
to see them.
And that's likely to stay the case for yours and I's lifetime, I'm afraid.
Yeah, nothing's going out there. They revolutionized the exploration. They revolutionized solar system exploration as well as interstellar exploration in the coming months. And the idea of the heliosphere and the heliosheath and the any other word that you can come up with, it's that research of the outer boundary of our solar system.
And what's great about them is that they're still being talked about. Like there's, in the past year, we've had so many news articles about Voyager 2, about it, breaching, or Voyager 1 breaching the edge of the solar system. So these are, 30 plus years or so at this point, spacecrafts that are just being, they just keep going and they keep making the news, which is so fantastic for an object like this that, we spent millions of dollars getting it into space and it's still going, it's still doing science, and it's still being talked about.
36 years later, that's exactly right. I mean, talk about amateurizing over a very long and ever increasingly longer period of time. I mean, it makes these probes dirt cheap. Really. I remember, again, ever so clearly the flybys of Uranus and Neptune. I know it was the flyby of Saturn. For some reason, I don't remember Voyager 2's flyby of Saturn quite as well, probably because it was literally the third spacecraft that did it. Pioneer 11 had previously flown by Saturn, and Voyager 1 had done it. I guess by the time I got to Voyager 2, it was almost ho-hum as it flew past Saturn.
Saturn.
Yeah, that's right. Been there, done that. I mean, we weren't even going to go visit Titan because it seemed to be a bit of a non-existing world. We'd done it with Voyager 1. Why do it with Voyager 2? But when we went by Neptune in particular, there was a great nostalgic moment because we knew that this was, if you will, the last hurrah for Voyager 2 from its imaging perspective. Leanne is absolutely right. It's still making great news as far as its investigation of the outer edge of our solar system. But we all knew in 1989, as Neptune was being visited by Voyager 2, that this was going to be the last really big imaging sequence of this spacecraft. It was going to be the fourth, the last of the Jovian worlds to be visited, and some of those preliminary images with the big dark spot, which has since disappeared, all of the wonderful imagery of this beautiful blue marble with white cirrus clouds. I mean, it was just a spectacular flyby. And it gained a lot of coverage. NASA was now broadcasting, 24/7 images, not to the internet, but on its NASA TV network. It was really, really special. And I took hours and hours and hours of VHS recorded footage just to make sure that, it would remain part of posterity. It was terrific.
And I think we could keep going on about Voyager 1 and Voyager 2, but I suspect that there's going to be an anniversary of Voyager 1 launch in the next week and a half or so. So I imagine we're going to talk about that next week. So let's save some of that for next week.
Absolutely.
On to the last one. I'm going to say this one because this one's really cool. I was doing some research for the one of the stories later on in the show that we're going to be talking about globular clusters. And in my research, I found out the person who was credited with the first observation and discovery of a globular cluster. So this is what I'm going to put out. It's a This Week in History. So the first globular cluster was discovered August 26th, 1665. That's your only hint. I'm going to put this into the chat room here and say, who was the person who observed and discovered the first globular cluster back in 1665? Throw that out to the chat room. Throw that out to Twitter. Throw it out to Facebook. Start answering that question, people. We will come back to that. So that's all I'm going to leave it at.
So you want them to name both the globular cluster and the person who found it?
Sure, yeah. I imagine this is going to go quick. This seems like Googleable.
There's a whole new vocabulary being generated.
Always.
Googleable.
Okay. So that's the question. Who discovered the first globular cluster? All right. And we'll leave that. Oh, even Michael got it wrong. Oh, my gosh.
Oh, don't make us big scene. Come on. Station ID time.
Are you kidding me? We stumped Michael. This is a big deal.
This is a good one.
Okay, let's move on from there. If you're just if you're just tuning in, everybody, you're listening to York Universe. This is an astronomy program we broadcast every Monday night from the York University Astronomical Observatory in Toronto, Canada. Tonight you have me, Jesse, along with Leanne and Paul. We just did our This Week in History bit, and now we're going to move on to a little bit of news, and Paul is going to introduce a little interview that we did off air earlier this week.
Absolutely. You might recall, if you were with us last week, that we touched on the fact that Canada's largest star party took place last weekend, Starfest, at the meeting place down there in Western Ontario, southwestern Ontario, near Mount Forest. Somewhere between 700 and 1,000 amateur astronomers getting together, having a terrific time with just absolutely stunningly fabulous weather. It was really, really great stuff. But that was all last weekend. But, of course, none of the team who were talking to you on Monday evening here on York Universe were available. So we decided that, we needed to speak to one of the people who was actually there. And as it worked out, there was half a dozen folks from the York University Observatory team who had decided to make the journey out there and observe under clear skies, to go kick a few telescopes, sort of metaphorically speaking, to be able to have a look through a variety of different telescopes. That's the real value of a star party. You can wander around the literally hundreds of telescopes that are set up for an evening observing. You can look through all of them. You can decide which ones you really like, which ones you don't like, the various qualities of each of the telescopes. And of course, there is no shortage of people who will talk to you about their telescopes. So it's better than going into an astronomy store where you will talk to the people who own the store. And of course, they're very knowledgeable, don't get me wrong. But here you've got the people who have had these telescopes out in the field. They know their eccentricities. They know their curiosities. They know their strengths and weaknesses. So any star party, and Starfest in particular, is a great place to go ahead and catch up with all these differing telescopes. And of course, by day, if you are actually sort of awake, because you've been up all night, but by day, if you're awake, you can check out the various presentations. There are professional astronomers, amateur astronomers who are giving a variety of talks. The comet theme was prevalent at Starfest last week. So all of that was going on here in southwestern Ontario. Everybody was having a terrific time. So we figured, okay, well, this is something that we've really got to get somebody who was there to talk about. And so one of the members of the Observatory team, you've seen them behind the scenes, if you will, for the online public viewing experience and so on, in the chat room, Amanda D'Souza. She is a student who is actually in her final year of her undergraduate degree, specializing in physics and astronomy. This time next year, she will have graduated and hopefully will be at graduate school somewhere. That is the plan of attack at the moment for Amanda. She's been with the Observatory team for at least 3 years, and it might be 4, so it's a number of years. So she's a little shy. We wanted to make sure that we cornered her, so as to speak, but she didn't want to do it as a live presentation. So we were going to do it via an interviewing process. And so I did this last week while we were all at York. And she was happy to do it. We only took a couple of takes to get it all straight. But she was definitely a very happy camper. And she, like all the other members of the Observatory team, had a terrific experience at Starfest last weekend. Good evening, Amanda. Thank you very much for joining York Universe tonight. The topic of conversation is about Starfest, which of course is Canada's largest star party. It's a wonderful experience. I can say that from personally going there on several occasions over the last, I won't tell you how many decades, but it certainly is a fun event out there at Mount Forest. You were there last weekend with the Perseid Meteor Shower and a lot of other people. Just like you to give some insight for our listeners about what Starfest was in terms of the way it was laid out and the way it was set up, and then we'll begin to talk a little bit about your experiences. So, what was Starfest last weekend, August of 2013?
It's a star party run by the North York Astronomical Association, and it started on the 8th officially, but they opened the park earlier for people who just want to come and set up. They had a bunch of speakers come in early in the mornings, and the last speaker usually would be at 7 o'clock. They kept time for lunch and dinner, but then the real fun started at 10 o'clock when observing started. And you see everyone with their telescopes set up, pointing at stars, and it's quite amazing. In the morning, you could also go walk around and talk to people about their setups, and you'd also see a bunch of solar scopes. So you could see those too. Next to the main tent, where all the speakers usually gave their talks, they had a bunch of vendors set up, usually like KW telescopes, Khan scopes, a place called New Eyes Old Skies. They were selling their gear over there. And they also were giving advice to people who were trying to buy new telescopes, which was really helpful because I was looking to buy a new telescope.
So it was obviously a bit of an astronomical smorgasbord of activities of people and so on. What was perhaps the highlight in terms of any of the presentations? Some really neat presentations from presumably professional astronomers or indeed, very serious amateur astronomers. Highlight from your point of view?
Someone came from NASA talking about comets. Can't remember his name though. And he was giving a talk about near-sun comets, which was quite interesting. But the theme, all the speakers, was pretty much comet hunting because of Comet Ison coming in November. That was very interesting. Our keynote speaker, which was Dan Mackhouse, I believe, gave a talk at the end about his comet hunting experience where he actually caught 11 comets. So he is the second, how do I say this? A person with the second highest number of comet hunting experience, I guess.
Found the second highest number of comets individually. Yep. So as you indicated, though, the real excitement began in the evening. So before I ask you what it was that you and the rest of the York team got up to in the evenings, about how many people were there? Are we talking dozens, hundreds, thousands?
I'm not sure, but estimates were at 700, which I believe, because when I came in, I saw like a flood of tents all over to the end. The best part of it all, each one of them was friendly. And I love that. The atmosphere was out of this world. I have never been in a crowd of people that were like me, and yet they had an experience where they could just share. So they were at a whole different level, but they still brought it down to my level, which was absolutely amazing. And I love every single person that was there.
Obviously, you were at home with 700 friends, and most of them you'd never met. So that was a good experience. And that, I think, is a characteristic of star parties in general. Anybody who is thinking about buying telescopes, or will amateur astronomy be, the hobby for them, trying to get to a star party is a real good opportunity. Okay, so what happened in the evening? What did you guys go off and try and observe, see? What did you do for those sort of long evening, cold evening hours?
Yes, it was quite cold. On the first night, we had clouds, unfortunately, so we didn't do much. But on the second night, after 1 o'clock in the morning, I believe, that's when it cleared up. And I don't have a telescope of my own, so I ended up bringing my DSLR camera and just doing astrophotography and just shots of the Milky Way because I don't have a rig. But the rest of the York crew, one was doing the Messier catalog, so just hunting down Messier objects, quite obsessively, I would add. And then Jen, who has been on the show previously, bought her telescope and was observing the moon before it set, and a couple planets. Another team member, Francesco, he hung around. But the fun part of it was not hanging around your own station, but walking around, because people were very willing for you to just come see through the telescope. In fact, we had a neighbor who told, I don't want to sound antisocial, but I want you guys to please come here and see my telescope. So it was absolutely amazing that people want you to come. And also another fun thing about walking around, even late at night, was seeing people who built their own telescopes, which was out of this world. Next to the main tent, they had, I'm not sure whether it's 32 or 36-inch telescope, a Dobsonian, which someone built, and they allowed you to see it. And I saw the double cluster on it. It was pretty cool.
Obviously, the evening hours were spent in astronomical bliss, I think would perhaps be the best statement here. And you're right, going to other stations, looking through other telescopes is really a very positive experience. Even if you're looking at the same object, they always appear different for differing scopes. Regardless whether or not it's reflectors, refractors, whether or not it's small or large aperture, they all are subtly different. From your point of view, is this a good experience for the novice?
It's an excellent experience for the novice. You do tend to get overwhelmed by everyone else's rig and you realize how much of nothing you have. But everyone is so willing to share their experience that you actually learn something. So you go up to anyone and you ask, I really like your telescope. If I want to do the same setup myself, how much would it cost me and all that? And everyone would help. So it's really good for the novice astronomer because you learn a lot. And everyone is so open that you'll feel like you're with family, I guess, with family and friends. They will help you out. So it's really good for the novice astronomer if you want to learn something.
Was this your first star party as a matter of interest?
Yes. And I'll go every year for as long as I can.
It will not be your last. Thank you very much indeed, Amanda. That's Amanda D'Souza from the York Observatory team, reflecting on her experiences at Starfest, Canada's largest star party, held this past weekend in August of 2013. So there you have it. Starfest as witnessed, as experienced by one of the members of the York University Astronomical Observatory team, Amanda D'Souza. Thanks, Amanda. You obviously had a terrific time, and to all of the participants at Starfest, not just the York Universe and the York Observatory team, but everybody who continues to make Starfest such a terrific experience, many thanks, and everybody, keep an eye open for next year, August of 2014. It's always in August, always in and around the first quarter moon and the Perseid meteor shower. So, terrific job to the North York amateur astronomers. Okay, so much for Starfest. That's history now.
Now, hold on.
Oh, no?
Sorry to jump in on you, Paul, but because we're ready to go with, we had the answer given. I gave the question beforehand.
Yes, yep.
And now the answer's here, so we should give it.
Absolutely.
The question was, I posed to the airwaves, the internet waves. This was part of our This Week in History. August 26th, 1665, who was the first person to discover a globular cluster, and which globular cluster was it? The answer given by, the cluster given by Jim Clusen in the chat room was M22, or what would become M22 later on. And the person given by John in the chat room was Abraham Eiley, however you pronounce that. We'll go with that. He was an astronomer, a German, I believe. He was actually observing Saturn at the time and was the first to discover M22. So good job, John and Jim.
Globular clusters, wonderful, wonderful observing objects. Summer sky, M13, M92, M15, they're wonderful objects. But anyway, I digress. Okay.
And it's related to a story later on. So if you like globular clusters, one of the stories later on tonight, we're going to talk about new globular cluster research.
Ooh, such a teaser. Okay, all right. I will move us along there fairly quickly because the next item on the news is one that I do not want to spend very much time on, but everybody will likely recall the relatively close approach of the planet Mars back in August of 2003. Okay, so we're talking about 10 years ago. Mars cruised within about 55.5 million kilometers. It was a terrific sight in telescopes, the largest apparent disk of Mars that most anybody listening tonight will ever see. Something I think probably about 25 arc seconds in diameter. I can't remember the exact size, but it was really big. You could see the polar ice caps, you could see the detail on the surface of Mars. But that was 10 years ago, people. Yet today, we still have the Mars hoax wandering around the internet. I personally have received already 2 inquiries in this past week, one from Australia and one from Toronto, asking about, quote, Mars's visibility later this month, and will it be as bright and as big as the full moon, and where should I be looking? If it was as big and as bright as the full moon, why would you be asking me where to look? At any rate, it's all wrong. Mars is not going to be terribly visible to us this time of the year. It is certainly not going to be as big and as bright as the full moon, and it is nowhere near the Earth, nowhere near the 55 million kilometers closest approach that it had back in 2003. Commonly referred to as the Mars hoax. If you get it in your inbox, please delete it. Do not pass it on because, of course, Mars is just not going to do its thing this year. Isn't going to happen. Okay, so the Mars hoax, please bury it, delete the emails, etc., etc. Mars, nice object to look at, but not this year.
It's funny how that stuff hangs around.
Yeah.
Oh,
Nothing
yes.
ever gets deleted from the internet.
It's like a boomerang. Okay, there's my Australian bit. Okay, I'm sorry.
That's your ballywick, man. We don't know.
Oh, very good. You've got that right. Excellent. Okay, so Mars hoax, dead and buried. Moving on, so
Dead and
Jesse.
buried, hopefully.
Yeah.
We'll see.
All right. Actually, I want to cut in here before we move on to our next news item. We have 3 people in the chat room under one name. Tina, Aiden. Oh, sorry, just Tina and Aiden. Aiden is a 9-year-old boy, and Tina is his mother. And they're asking the question, Aiden would like to know if it would be possible to look at the ISS. So I pose that question to you two.
Depends. You can absolutely see the great question, Aiden, because the International Space Station is the most sophisticated thing humans have ever put in orbit, ever put into space. It's the size of a football field. The thing is huge, massive, yet it's 400 kilometers up. Can you see something that's 400 kilometers up? And the answer is absolutely yes. You can see it traveling across our skies. There's a great websites there. One is ISS Tracker. That's the best one. If you go to isstracker.com, and this has been posted in the chat room. I'm not sure if they're actually listening or just in our York Observatory chat room. But if you go to that website, you can check it out. You can actually look for bright or not so bright ISS passovers. They go over all the time, and you can absolutely see. You don't even need binoculars or telescopes. You just need your eyes. And now you can't get any detail. It's going to look like a star that's slowly going overhead. But it's only going to be up in your sky for about 5 minutes. It goes really quickly. And
when it's one of the brighter passes, it looks phenomenal. Like it looks like the Venus is actually moving across the sky, and you can definitely tell it's not something that normally goes across the sky. It doesn't. It could. People often mistake it for a plane, but there's no flashing. It's just this bright star that moves across. But I want to just add on to that. If you do have the chance to look at it through telescope or through binoculars, it takes a little bit of skill to be able to track it. But if you do, it is absolutely one of the coolest things you'd actually see. Yeah, you actually see the solar panels. You can see the structure of it. It's like that scene in Star Trek First Contact when they look through the telescope at the Enterprise and you see the Enterprise. Shut up. I'm cool.
We have a nice archival image, if the chat room folks are listening. It was taken by one of our observing staff, Zengi Hugh, from about 3 years ago. And it does show detail taken through the 40 centimeter telescope. So yes, Leanne is absolutely correct, but it is a challenge to see that level of detail because it is moving very, very quickly. But you can do it. But the other comment, just to be very clear, the ISS for any given location on the surface of the Earth won't necessarily pass over your location during the nighttime, okay? Because of the inclined orbit of the space station, even though it orbits the Earth once every 90 minutes, because of something called its ground track or its ground path, that path doesn't always take it, the International Space Station, over a specific location on the Earth's surface every single night. There are what we call observing seasons or observing passes where in a period of a few days, maybe a week or so, it will be, in fact, the ISS will be visible in your sky every single night, maybe even a couple of times a night. But that's where that ISStracker.com comes in. Once you feed in your location, it will tell you when the ISS will in fact be visible in your nighttime sky, when it'll be, as everybody has said, really, really bright. So it's not every single night, but certainly if you're patient, the ISS will pass over your particular location on the surface of the Earth, likely a few times every single month. But that's where ISS Tracker will come to your aid and tell you exactly which night and at what time of night, what direction to look, and what direction it'll be passing across your sky. So well worth the time spent figuring out exactly where to look. And as Leanne and Jesse have said, and I concur, it's an amazing site. It's well worth the time spent finding it.
Yeah, there's a lot of good things to talk about. Like I can't even get into the philosophical awesomeness about watching something man-made orbit the Earth at 30,000 kilometers an hour. That's fantastic stuff. Let's move on to more news because we could stay on that.
Yep, I think it's me next. So there's this cool planet that was actually narrowed down a couple of weeks ago. So it's Kepler 73b, I believe. I'm just trying to pull up my news item here. It's a planet that's orbiting around the sun, but it's moving very, very fast. So how long do you go to work for, Paul? 7.5, 8 hours, 8.5 hours, 9, something around that?
Close enough.
Close enough on during the summer, let's use those.
On average, absolutely, that's true. Yeah.
Sure. So that's about my workday too. 8.5 hours. That's how quickly this planet actually orbits around its sun. It is moving super, super fast, and it's actually super, super close to its host star. So the cool thing about this one, it was discovered by Kepler originally, just using the transit method, in which it passed in front of the sun, or in front of its star, and created a dip in the light. We were able to detect it this way. They were able to gather further information about it by actually detecting the light from the planet. So this is actually, being able to directly image that actual light from the planet. And this is the smallest planet that we've been able to do this with. So we're actually getting closer and closer to smaller and smaller planets with different techniques. Thank you. So the cool thing about this is that we're getting closer to smaller and smaller planets. We're being able to pick them up closer and closer to the star, and we're refining all these different techniques to be able to pick up all these guys. There's one other thing I wanted to bring out with this is that so it's not actually the fastest planet to go around its star. There's another one that's at 4.5 hours. So this other one is zipping around like crazy. And again, it's going to be very, very close to its planet star. So these aren't going to be habitable. It's just not possible. There's the one that's moving around at 7.5 hours. It's actually lead. It is so dense and it's so hot that there's no possibility, or there's almost no possibility of life being detected on it. This one, Kepler 78b, which is at the 8.5 hours orbital period, again, it's going to be very, very hot and very, very close to the star, and it's not going to have light. But I think it adds a little bit more to the idea of what makes up a solar system. We're getting closer to, say, to the Mercury-sized planets, to even like the Venus and Earth-sized planet. We're getting more and more. We're filling out the range of these planets, of the different sizes of the planets, which are adding to the whole story of planetary formation and our whole exoplanet population. So I think that was a cool one to find.
particularly exciting about this observation is that we're detecting reflected light from the planet, which means not reflected light. We're detecting, its own direct light emissions, which means we stand the chance of being able to make elemental determinations what makes up that particular planet. And we think we know what a planet is going to be made of, but to be able to actually point to a particular planet, say Kepler 78b, and say this planet has the following elements confirmed within it, that to me is really neat.
It gives us more of a census of the type of heavy materials that are being created in the galaxy. And in different systems, which is, really great and fundamental. We can learn a lot about the gases that are in our galaxy and in our universe, but we don't know a lot about the actual, heavier elements, because they're mainly found or a lot of them are found in solid form, and that is a lot harder to emit different spectral lines to be able to detect it. So this adds another way of seeing it, because we're actually looking at the hard light being emitted from a planet.
Three cheers for spectroscopy. Three cheers for spectroscopy. Hip, hip. Okay, right.
This
Excellent
is a question
stuff.
I have, though. So you need spectroscopy to observe these. If you want to observe the light from a planet and then understand what chemicals you have on the surface, you need to do spectroscopy. Which telescope was being used? I'm trying to find it right now. And does anybody know? It's got to be. It's got to be Kepler. Sorry, it's got to be Keck.
Yeah, because Kepler won't. Kepler's just...
Kepler can't do it. It's an imager. Yeah. It's got to be Keck, because Keck has the collecting area you need, and these planets are tiny. I can't imagine... Well, there's probably some other telescopes that are pretty powerful, but Keck is one of the biggest ones, and I was just trying to find it. No big deal. We'll track it down and throw it in the show notes.
You're probably right, but I don't remember reading that in the article either.
Yeah, it just notes a journal, astrophysical journal letters that it was talking about. So I'll look that up while we're doing it, and we're moving on, and maybe by the end of the night we can talk about it.
I'm just interested from an instrumental point of view, because there's only certain telescopes, I think, capable of doing this, especially with them as small. There's stories about other exoplanets that are big ones. We're talking like super Jupiters that are, like you're talking about, like studying those kinds of atmospheres. But I'm really doing something. How big is this planet? Sorry,
It's quite small.
It's a super tiny planet. For ones as small, I didn't think we were there yet, but apparently we are.
This is the closest to the planet.
Yeah.
It may not be...
Yeah, sure. It may not be...
Maybe a few Earth sizes or so. So it's not... It probably isn't the size of Jupiter. It is a rocky planet, but it may not be down to the size of Mercury, even that far, but it is super close to the planet, to the star, and we're able to detect the light itself, which means that we're getting closer and closer to picking up these very, very small planets this way.
This is big stuff. Like, if you're able to study the atmospheres of other planets, like you're going to be, that's a whole doorway into an entirely new field. In fields, like multiple fields, like this is groundbreaking stuff, and people got to remember that this stuff has only been around, like studying atmospheres of other planets has only been around for the last less than 10 years.
Right.
It's the earliest stuff was in the mid 2000s, I think, roughly. And planets were only discovered back in '95. This is groundbreaking stuff.
Yeah, so it's 20 years roughly since the first planets were detected, and then we're moving on to now we're actually detecting atmospheres of planets. We're detecting chemical compositions. We're getting it's no longer is there planets outside of our solar system. We know that. We've seen so many. Now it's what type, what form, what governs different sizes of solar systems, because we're seeing them everywhere. So it's neat. This is a cool find. I just want to put in there that this planet was roughly the size, a little bit larger than Earth.
1.16 times.
There we go.
Yep, the radius of Earth. Haven't got a mass, but 1.16 times the radius.
Minimum mass is, maximum mass is 8 times the mass of Earth. So
wow, it's a lot of lead.
Could be quite, but it may not be. Well, it's probably not made of water. So
yeah, probably.
Right.
Probably doesn't have chemistry. So,
not at a surface temperature of 2,000 to 3,000 degrees Celsius.
No, probably not.
Okay, it's already 9:45. We should probably move on to some more stories.
What's unusual about us running over? Come on. Okay, go on.
I'm just going to quickly mention this story, even though it's a pretty big deal, because I want to move on to some of the other stuff that we're talking about. The last news item we have is that there was a new nova observed in Delphinus. Delphinus is one of the smallest constellations out there. It's just to the bottom left of the Summer Triangle, just left of
little dolphin.
a little tiny dolphin.
Yeah.
The mammal of the sky.
Yes.
And the
Mammal of the sky.
and
There's no kangaroos
Delphinus just a little left of Altair, which is part of Aquila, I believe.
Yes.
Am I learning my constellations? This is
You're
good.
doing well. You're doing well, yes.
So in Delphinus, in the constellation Delphinus, a new nova was observed. This was back in mid-August, August 15th or August 14th, where it was noted and then very quickly after confirmed as a new nova, which is sort of like a mini explosion on the surface of a star or surface of a white dwarf. I can't remember.
Yeah, white dwarf, yeah.
Yeah, I okay, make sure I had it right. Yes. So basically a white dwarf would have been accreting some material. A little bit too much goes into that. It's not enough to make a supernova happen, but it ends up sort of creating a big explosion, sheds all that material off of it, and it is very bright. In fact, this one was noted to be at 6th magnitude, so right at the edge of observability with your eyes alone. But a pair of good binoculars would pick it up too. So I recommend anybody who's an avid observer who likes going out and catching these kinds of things, head out to Delphinus and check it out because it could be getting brighter.
Good finder charts in Universe Today. Good finder chart in Sky and Telescope. For those folks who are familiar enough with the evening sky, it is north of the head of Delphinus or Delphinius. But I find that the arrow, Sagitta the arrow, is pointing straight at it. So Sagitta the arrow pointing towards the west is almost a dead giveaway to where this supernova is. So easy to find with binoculars, arguably easy to find with telescopes as well. It will be fading fairly quickly over the next few days to next couple of weeks. So it would be an excellent opportunity to go out and see real change happening in the night sky if you can locate it in the next day or two while it's nice and bright, and then track its fading brightness over the next week or two.
Maybe we should try and take a picture of that. Anybody in the observatory pointing it at Delphinus? Check it out.
Remember, we've got a tour that's running there, but if they get a chance afterwards with the webcam, that's what they will try and do. That is on their agenda. We'll see what we can come up with. If you've just tuned in, you're listening to York Universe, the weekly broadcast of astronomy and astrophysics coming out of York University's Astronomical Observatory here in Toronto, Ontario, Canada. Of course, we're leading off Astronomy Night in Canada here on AFM Radio. You're listening to Jesse, Leanne, and myself, Paul, wax relatively eloquently about all things in astronomy and space science. If you've got a web browser open, by all means, head over to yorkobservatory.com. Join the chat room, and if you've got questions, feel free to ask. Okay, Jesse, on to real news now.
Real news? That wasn't news before? Well, I wanted to... So the reason this is a fun story for me, because it sort of traces back to myself just entering into astronomy, and the story is about dark matter, which is arguably controversial. There's a lot of evidence out there. If you're doing some observations of, say, galaxy clusters or the rotation curves of galaxies themselves or various other things, there is a large discrepancy between what you expect the motion of the stars or galaxies to be doing and what they actually are doing. The famous example being Fritz Zwicky doing an observation of galaxy clusters back in 1933, and he observed them to be moving much faster than they should be given the amount of mass there. Now, over the next 80 years or so, the solution to this problem became dark matter. And this is a large amount of unseen mass that we can't see, doesn't radiate, doesn't interact with anything, but has to be there in order to explain the observations of galaxies and stars in the universe. So that's sort of the very short story history of dark matter. Now, it wasn't the only explanation. There was a faction began in 1983 by, I forget his first name, but the Dr. Milgram, And he proposed, instead of there being a need for a very large amount of unseen matter, why don't we just change the rules of gravity? And so he came up with this thing called modified Newtonian dynamics, which has subsequently been changed by various, or added, and other things have popped up, different types of modified gravity. But basically saying there doesn't have to be a lot of extra mass. We just have to have different rules for gravity. We don't know what gravity is like on scales that big. We haven't tested it on scales that big, so maybe it's different than what, say, Newtonian or general relativity would say. And then there's been this huge battle between dark matter and modified gravity. Which one's right? That's sort of the big controversy. Now, dark matter is sort of heralded as the answer. Most astronomers would agree with dark matter, but it's not a small faction of astronomers that are still on the modified gravity side. So it wasn't until 2006, and this is where the story gets interesting, where there was some really definitive evidence that was able to or really definitive evidence that was able to land on one side more than the other, and that was this thing called the bullet cluster. So, yes, thank you, Paul. Mordechai Milgram. I almost had the right. I had the right last name, right?
Yes, you did.
Okay.
You're doing fine.
Okay, so the bullet cluster. The reason this helped solve, and it's still an ongoing problem, but this was one of the solutions at the time. The bullet cluster was two clusters slamming into each other. And if you imagine a cluster to be made of, a cluster of galaxies is just, it's galaxies, and then there's in between the galaxies, there's this hot gas called plasma. It's not even gas, it's plasma. And in between, this plasma hangs out in between the galaxies. Now, the plasma in a cluster, most of the mass hangs out in the plasma, and then if there's dark matter, most of the mass also hangs out in the dark matter. If you were to collide two galaxy clusters together, here's what's going to happen. You collide them, the galaxies are going to move right through each other, like the galaxies will just pass by each other like bowling balls, billiard balls. They're collisionless particles pretty much. They're just going to keep moving. But the plasma is going to slow down. It's going to stop. The plasma in the two clusters is going to ram into each other, and the plasma is going to stop. So what you're going to end up with is physically separated galaxies from plasma. Now, if you map the gravitational potential of that, and you assume there is no dark matter, then most of the gravitational potential should be with the plasma, because that's where most of the mass is. So what they did for the bullet cluster was they mapped the gravitational potential of this cluster and found that most of the mass was hanging out with the galaxies, not with the plasma. Now, since we know that galaxies weigh less than the plasma, that means definitively that there has to be more matter there, and there's no modified gravity that can account for that discrepancy in observation. So that's a really short history of the rise of dark matter, and in 2006, a very big piece of evidence to support its existence, though many professors will be quick to point out that there are new versions of modified gravity that could possibly explain these. The bullet cluster and similar clusters that have been found since, though they're still kind of tough to talk about with modified gravity, but MOND has been kicked out for sure. Definitely doesn't agree.
This whole debate about what is dark matter and the various evidence of it sort of strikes me as a little bit reminiscent of the debate over galaxy redshifts, quasar redshifts, that was taking place in the sort of the 40s, 50s, and even into the 60s. Were the objects that we were detecting receding from us and therefore shifting spectral lines so far into the red end of the spectrum that it implied that the recessional velocities were staggering? Even though we knew the universe was expanding, there was still a belief that some of these objects really shouldn't have been that far away, and that the redshifts that we were detecting were not really redshifts at all. There was other explanations associated with it. I remember Jeff Burbidge and company were the proponents of this, that they didn't believe that the various spectral lines associated with very distant quasars really were redshifted that far away. This whole debate about modified gravity versus dark matter has, to me, a bit of a similar feel. We seem to be repeating history in this regard. to me, and this is not my field of expertise by any stretch of the imagination, but the evidence to me seems very strong for dark matter being some form of matter, part of the standard model that we just have yet to detect. The notion of tinkering with gravity to replicate the results somehow just doesn't sound right to me. And that it's a gut feeling. It's not based upon science per se, but to me, dark matter being particulate material of some description seems to me to be far more accurate.
I don't know a lot about modified gravity, but I've always felt that it has this feel of, okay, my answers don't really quite fit my math, so I'm going to screw around with my equations a bit until they do.
Sounds like my undergrad assignment.
A little bit, yeah. But so it has this sort of uncomfortable that you're trying so much to make our current ideas fit with what we have or what observations are telling us.
Okay, now what I will say though, and I don't want to sort of make a fake controversy. I don't want to balance the sides, because this is something that happens with climate change as well, where you balance the opinions when the opinions are not balanced. Dark matter is definitely seemingly the answer, even though there are some holdouts for modified gravity. But to respond to what you're saying, and what these people will say, is that dark matter seems just as random as modifying the gravity rules. Like, how can you just say, oh, there's matter? Now, I agree. Dark matter seems like the right answer, but they would say, oh, where are you getting this idea of extra matter from? That's sort of the way they say, and
I can understand that.
But if you're mapping if you look at the bullet cluster and you map the gravitational potential, and you see that all of the gravity is there, and there's no way to explain this with your modified rules, then that's sort of it's kind of a big deal.
Yeah, it's the fact that before the bullet cluster came out, it was, things aren't matching up exactly. We could be wrong on this, which is the modified gravity scheme, or there could be this new thing called dark matter. And then the bullet cluster came along, and they had to revise their method of doing a modified gravity method of doing things. Like, oh, maybe it still doesn't mix in. Maybe this doesn't work. Where dark matter, it still made sense. It still was consistent.
Yes.
And it's the simplest explanation in most cases, which doesn't mean in any sense that it's right.
That's true.
It's just, I've always not liked something that you just have to keep trying to catch up with evidence and modify so much when you're not really able to rely on it in the I guess the first level observations.
Yeah.
You know what I mean? We're never going to be perfect, but dark matter makes sense right now.
Keep it simple. The simplest answer is often the correct one in science, the KISS principle. And to me, that suggests dark matter.
Yes.
Bless you.
But it would be super cool if modified gravity was right, because then there'd be whole new science to investigate, which would be awesome. So.
Oh, I'd have to go back to school. I've been there. I've done that. I'm sorry.
Yeah.
Interesting stuff, though, Jesse. You're absolutely right. And it just shows you that, despite observational evidence pointing strongly in one direction, doesn't necessarily put the nail in the coffin just yet.
And I will say, the reason I like this, I said, when I was in fourth year undergrad, I started doing an undergrad thesis, which means I joined a research team. I joined a professor, and I was researching under a professor. And I remember going to one of my first meetings, and we're supposed to bring papers to sort of bring a paper. There's 5 of us at the meeting, and you bring a paper from the literature, and you talk about the paper, and you sort of try and understand what they're talking about and present it. And I didn't know what I was doing in fourth year. I mean, I thought I was smart, but I wasn't smart. And I brought a MOND paper because I had never heard of MOND. And I was in fourth year. Dark matter was always the answer. I was like, oh, what's this cool MOND thing? And I got these groans at the research meeting. They're like, why'd you bring this paper? It was really funny.
But you could be offering a new perspective to it. So it should be, all right, you don't know.
I didn't know anything.
You don't know.
So.
That's also a thing that goes on in science a lot, though, is that there is a lot of pushback against any theories that aren't following. My reaction to this, even to what you were saying, is, I don't know, this is kind of, where there's a lot of that. And you being a fourth year student, bringing this new paper that, is controversial. There is this groaning factor, but you could be offering new theories. You have fresh eyes on it. what are these galaxies? They're just nebula. They can't be anything outside our galaxy. That's crazy. Yeah, you're right. It's these changes in how we think about the universe that really push how we understand the universe. Like, we kind of have to break out of our boxes in order to expand what we know and think is true. So it's always good when things like this come up.
Absolutely.
Shall we move on to our next story?
Sure. Which next story do you want to move on to?
Well,
we've probably only got time for one.
We're running out of time. I think. I don't know. Why don't we do the globular cluster story?
I like globular clusters. We teased it earlier.
Oh, that's true. We have to talk about it.
Yes, you do.
That's true. Okay.
We'll move pulsars to next week.
Yeah, we'll move pulsars unless we get some time. I don't know how much time we have. We're already over budget, so let me jump into this quickly. Globular clusters are a type of cluster, very compact, lots of members, hundreds of thousands to millions of members in a globular cluster. We observe them in the Milky Way, obviously, but we also observe them in other galaxies. And there's this sort of problem going around. Well, it's not even really a problem. What they were doing is they were observing the globular clusters in as many different galaxies as possible, and then measuring their size and their mass, or measuring their size and their luminosity, I guess, and sort of putting them all on a plot. And they were doing this so they took the ones from the Milky Way and they put them on a plot. And they took ones from nearby elliptical galaxies and put those on a plot. And then they took globular clusters from ultra compact dwarfs and put those on the same plot. And you throw all the sizes and the luminosities of globular clusters on a single plot, and you see what happens. And this happens a lot in astronomy. Let's graph something and see what happens. What was happening was there was this section of this graph of size versus luminosity of globular clusters, and there's a section that was being statistically unfilled. There was not a lot of members in this region, particularly high or big size. They didn't have a lot of big sizes of globular clusters, and they were sort of hanging out in sort of the mid-range of luminosities, and they called this an avoidance region, or a gap, a size luminosity gap, where globular clusters didn't seem to be landing. For some reason, it looked like there's no types of globular clusters that were of this specific size and there's this sort of that there are multiple different types of globular clusters that originate in different ways and evolve in different ways. And so this gap on the graph in this region is basically hinting towards those different origin stories and the different evolution. All right, fast forward to this new paper that's come out. It came from the Keck Observatory. I love the Keck Observatory, by the way.
Pretty awesome.
They do a great job of outreach because their blog is always updated. Anyway, some people use the Keck telescopes to look at some more galaxies and get a much larger sample of globular clusters, measure their sizes, measure their distances, measure their luminosities as proper as possible, and found that, lo and behold, they were now populating this gap on that graph of globular clusters. This region that was not supposed to have any, that was, if there were different types of globular clusters, shouldn't have any. So this group was basically saying, look, we found these globular clusters that weren't supposed to be there. What does that mean? So, what does that mean? Basically, that means that we are only as good as our observations are. We were very limited we only had the globular clusters from nearby galaxies and us. Measuring the size of a globular cluster is totally dependent on your ability to resolve the cluster itself. And then measuring the luminosity is totally dependent on distance or something along that line. Mm-hmm. So you need better observations to make this stuff happen. And this is what this seems like to me in reading the story is basically an example of there's a region on this graph that it's not stuff that doesn't exist. It's stuff that was hard to see. It took us a long time to find them.
And we've seen this a lot throughout literature and the history of science for a while. Jesse and I were talking before the show about the big gap that existed between quasars and Seyferts, which are two types of active galactic nuclei. So you have the quasars, which are really, really, really bright, high luminosity, very, very far away, and then you have the Seyferts, which are close by, fainter. And there was this gap between them that you couldn't really find anything that was...
And the funny thing is that even with Seyferts and quasars, is they were totally mutually exclusive groups.
Yeah.
People weren't even talking to each other.
No, they were detected independently. People were like, I have this cool new nearby galaxy that's awesome. And then quasar people were like, nope, my guys are awesome because they're far away and they're really bright. And then we found out that they're one and the same. They're slightly different, but they're all part of this broader AGN classification, or active galactic nuclei classification. And this is what it seems like in the case of these star clusters, is that our detectors can only detect what they have the capability to detect.
Yeah, I know that sounds naive, but that's true. Is that you're only as good as your best telescope, and there's this region on this graph that we couldn't fill, but using extended observations with Hubble and Keck, this is a big thing going on. They use both those big telescopes to measure this larger sample of globular clusters and fill in that gap of size and luminosity.
Right.
So it's sort of like that cautionary tale.
Now, these globular clusters are orbiting around the Milky Way galaxy, right? We're not looking at globular clusters around other galaxies?
Very much so, around other galaxies. There is a large chunk of all 150 whatever galaxies or globular clusters from our galaxy are on the plot, but also from ellipticals and ultra-compact dwarfs.
Okay, sorry, I missed that point. Okay,
and
all right.
this
I mean,
looking at a bunch of NGC objects.
Okay, and of course, the importance of globular clusters is that they basically talk to us about the earliest moments of galaxy formation. They are basically older than the galaxies about which they are orbiting, or at least as old. And so understanding more and more about globular clusters, including their distribution, talks to us in a serious way about the galaxy's formation.
And we could go on and on and on, but we should probably wrap it up.
That sounds about right, given the fact that we're already 10 minutes over or thereabouts.
Yeah. So everybody, if you have spent some time listening to us tonight, thank you. You brightened our day, and hopefully we brightened yours listening to York Universe. From here in Toronto, Canada, you had tonight myself, Jesse, along with Leanne and Paul. If you have any questions, comments, or anything about what we've talked about tonight, or stuff you want to talk about in the future, go to yorkuniverse.com, Facebook, or Twitter, because we like talking and we'll continue to talk. From everybody here at York Universe, thanks for listening. Have a good night.
Good night, folks, and by all means, stay tuned to the OPV. They're still snooping around in the chat room. By all means, stay tuned with them. We'll see you all next week. Good night.
Good night.
We hope that you've enjoyed this program from AFM Radio, the broadcast service of Astronomy.fm. This program has been released under Creative Commons license. Please contact us for details. You may find more of our AFM original programs on our website. It's really easy to find us. We are Astronomy.fm. You may also find us in the iTunes radio listings near the top of the News Talk section, and also as an iTunes podcast selection. We'd love to hear your comments. Please email us at radio@astronomy.fm. Thanks so much for being part of the voice of astronomy around the world and across the known universe. This is Astronomy.fm Radio.
AFM.